Welcome to NSMO, the National Science and Mathematics Olympiad. In this lesson, we will learn the different methods used to represent the electron configuration of an atom. Understanding these methods helps us describe how electrons are arranged around the nucleus in a clear and organized way. There are three main methods used to represent electron configuration, and we will explain each one using carbon and then apply them in an exercise on phosphorus. Method 1, electron configuration notation. Let's start with electron configuration notation. This method uses numbers and letters to show how electrons are distributed among energy levels and sublevels. For example, carbon has an atomic number of 6, which means it has 6 electrons. Its electron configuration is written as 1s2, 2s2, 2b2. This tells us 2 electrons are in the 1s sublevel, 2 electrons are in the 2s sublevel, 2 electrons are in the 2b sublevel. The superscript shows the number of electrons in each sublevel. Method 2, drawing orbitals energy level box in box diagram. The second method is drawing orbitals box diagram. Each box represents an orbital. Each arrow represents an electron. The arrow direction shows the electron's spin. For carbon, the 1s orbital has 2 electrons with opposite spins. The 2s orbitals also has 2 electrons with opposite spins. The 2b sublevel has 3 orbitals but only 2 electrons, so they occupy separate orbitals first. This follows Hund rule, where electrons fill orbitals singly before pairing. Method 3, noble gas or core notation. The third method is noble gas notation, also called core notation. In this method, we replace the inner electrons with the symbol of the nearest noble gas that comes before the element. Carbon in period 2, so we can use helium written as helium between 2 brackets. So carbon's configuration becomes helium 2s2, 2b2. This method is shorter and very useful for larger atoms. Important rule for noble gas notation. When using noble gas notation, we always choose the noble gas from the previous period, not the same period. For example, sodium has atomic number 11, is in a period 3. The noble gas before it is neon 10. So sodium's configuration starts with neon. Now let's move to the exercise. Write electron configuration of phosphorus P15 using the following method. First, electron configuration notation, drawing the sublevels orbital box diagrams, noble gas notation. We'll start with the first one, electron configuration notation. Phosphorus has 15 electrons. filling orbitals in order gives 1s2, 2s2, 2b6, 3s2, 3b3. Orbital box diagram. In the orbital diagram, the 1s, 2s, and the 3s orbitals are fully paired. The 2b orbitals are fully filled with 6 electrons. The 3 sublevel has 3 electrons placed, one in each orbital with the same spin. This satisfies both Pauli exclusion principle and Hund's rule. The last one, noble gas notation. The noble gas before the phosphorus is neon. So the noble gas notation it will be neon 3s2 3b3. We can summarize our lecture today. Electron configuration notation shows full details. Orbital box diagram show electron spins and orbital filling. Noble gas notation provides a shorter, efficient representation. All 3 methods describe the same electron arrangements, just in different ways. In the next lesson, we will continue using this method to understand periodic trends and chemical bonding. Thank you for learning with NSMO, and keep exploring chemistry with confidence.